Okay, let's have a look at section 2.4, average speed and average velocity. Let's just jump straight into it. An object's average speed is the distance traveled divided by the time. Okay, so average speed is distance. Okay, distance divided by time. We know that this actually is a scalar. Distance is a scalar, so speed is a scalar. Then average velocity, and we'll look at an example. Average velocity is displacement, right, over time. This is a vector because displacement is a vector. Average velocity is a vector. Now let's look at the example that we've seen all throughout the textbook. Let's look at that man walking again. So remember that the man started at a certain position. He walked a bit forward, then he began to reverse. And you can see that in this graph as well. He walks at a starting, his initial position is 1 meter. Then he walks forward up to 4.8 meters. Then he stands still for a few seconds. Looks like maybe just under 2 seconds. Then he begins to walk backwards. Okay, so let's try and look at his average speed and average velocity by looking at this data. So here's another way of looking at it. So at time 0 he's at 1. So if there's my reference frame, x equals 0 there. He starts there, right? That's 1 meter. He walks forward, and then he stops and he reverses. Okay, so if that's his starting position is 1 meter, then that maximum position, if you recall, is 4.8, measured from this reference frame. Then he begins to walk backwards, and then that is x equals 3.4. Okay, so he starts at 1. He increases 1.5, 2.2, 2.8, all the way to 4.8, and then he stays at 4.8, maximum that 4.8 distance, and then he begins walking backwards, 4.6, all the way to 3.4. Okay, very good. Now, what we need to see here is that the average speed is the distance over time. So what is the distance? Remember, the distance is the total path. The distance is the total path. So what is the total path? Let's change colors. What do you want? How about yellow? Okay. The total path traveled is that. That's the total path. So that means it is this entire distance. That entire distance. So this is 4.8. That's 1. So this length here is what? 4.8 minus 1 is 3.8. Okay? And then this distance here looks to me to be 1.4. Right? So 3.8 and then 1.4. So what is that? 3.8 plus 1.4 over the time. And what is the entire time? The entire time is that entire thing there, which is 6 seconds. 6 seconds. So 3.8 plus 1.4. Let's see, they've actually done it here. It's 5.2. 5.2 divided by 6 is 0.87. So that is 5.2 divided by 6, which is 0.87 meters per second. And this is the average speed. Average speed. Okay? It is the total path. The total path. Now what is the average velocity? The average velocity, remember, I'm running out of space here. Oh wait, let's move to the right. There we go. The average velocity Let's do this. Average velocity is displacement over time. What is the displacement? It is the x2 minus x1, or x final minus x initial over time. What is the final position? What is the final position? The final position is this. That's your final position. There's my xf, 3.4, and it's plus, right? And what was my initial position? My initial position was 1. So plus 3.4 minus positive 1 divided by 6, which is then 2.4 divided by 6, which is, I know it looks obvious, but I don't want to make a mistake here in front of you. 2.4 divided by 6, which is 0.4 meters. Where was I? I was here. 0.4 meters per second. So that is my average velocity. You see the difference, guys? See the difference? Average speed is distance over time. Average velocity is displacement over time.